Welcome to trigonometry. This is going to cover 2 units in this course, and this first unit focuses on trigonometric functions. We're going to look at the 3 trigonometric functions that you already know, plus 3 reciprocal trigonometric functions. And we're going to talk about how we can use trigonometric functions to solve problems involving angles, and also how we can actually graph our 3 basic trigonometric functions: sine, cosine, and tangent. To start off with, we're going to have to review a little bit of vocabulary from possibly earlier grades, but most recently from pre-calculus 11. So if we have an angle, the angle right here is this piece. Okay, kind of the sideways that's created, the pocket that's created when you have 2 lines that meet. The corner right here is called the vertex of the angle. And the 2 lines that are the ones that meet can be called alternately the arm of the angle or side of the angle, depending on which you like. So an angle is formed when 2 arms or sides meet at a vertex. Okay, so when we're talking about trigonometric functions, we use angles in standard position. And the standard position is something that you covered in pre-calculus 12. Okay, so angles in standard position are drawn in the coordinate plane. And when we're in the coordinate plane, we consider it having 4 quadrants, which are given by the Roman numerals 1, 2, 3, and 4. We call these quadrants. Quadrant 1, 2, 3, and 4. You can also name them using numbers. I probably won't deduct marks if you don't use the Roman numerals. But the quadrants go around in a circle counterclockwise. Similarly, we call an angle in standard position is called theta, where the vertex of the angle is at 0, 0. One arm or side of the angle is the positive x-axis, and the other arm or side of the angle is rotating, and so it rotates counterclockwise starting from the positive x-axis. So we're measuring the angle from the positive x-axis, which is right here, up till we get to the other arm. And we call this arm here the terminal arm, or the terminal side, which is where the angle ends. And this arm here, the positive x-axis, which is always the positive x-axis, would be called the initial arm or side. Okay, so angles in standard position are measured counterclockwise from the positive x-axis. Okay. So what we are going to be doing is we are going to be looking at how are angles traditionally measured? Well, if we have an angle, we are going to be measuring using a tool called a protractor. So you have a protractor and it's got like a little dot here, and then you measure going around here. Up here at the top is 90 degrees. All the way around down here is 180 degrees. Okay, and we start here at 0 degrees. So a protractor would measure an angle based on placing the initial arm down here and then the terminal arm up here, which would allow you to get this sort of round measurement for how many degrees the angle is, so how many degrees it goes through. And we're thinking about the fact that we have our sort of basic 4 corners measurements. We know that 90 degrees is a quarter of the way around the circle. 180 degrees is halfway. 270 degrees is 3/4 of the way around the circle, and that 360 degrees makes a full circle. So the limitation of using degrees for measurement is that they're actually a different system of measurement. We can't convert them into a distance or some other kind of flat measurement. So when we're using X and Y coordinates, these are distances. Sometimes we would actually like to be able to measure our angles using the same kind of thing we're using to measure our X's and Y's. So we're going to come up with a new way of measuring, okay? So what we're going to be looking at is we're going to be looking at what is called a radian, okay? So how do we define a radian? So let's think, as we've been talking about how many degrees around a circle we're going, let's think of drawing a circle. As you can see, I can draw a nearly perfect circle. We will have this circle with a center at the origin, and we're going to think of the angle as starting here on the positive x-axis and rotating through. So what we want is 1 radian. So if we think about the radius of this circle r, okay, we want to think about the point, we think about rotating this terminal arm up counterclockwise from the x-axis. What we're looking at is we're looking at a point where the length of the radius is the same as the arc length that's cut off by the angle. So we want this measurement here, this flat straight measurement, to be the same distance as this kind of, if we were to take this round piece of the circle and as if it were a piece of string, straighten it out, we want those two to be the same. So if we have a theta here, so the arc length is equal to the radius of the circle, we would say that the measure of angle theta equals 1 radian. Okay? So an angle, and just for the definition verbally, an angle measuring 1 radian has an arc length between its initial and terminal arms equal to the radius of the circle drawn. And what we find is that no matter how big we make that circle, the angle for 1 radian is going to be the same. You can stretch or shrink it, but the proportion is actually going to stay the same. Okay, so now we have our new unit of measure, 1 radian. And the nice thing about a radian is that that radian is based on a distance. So it's essentially how far has the terminal arm gone around the circle. 1 radian means it's gone 1 radius. That actually works out to about 59 degrees or so like that. But we want to be able to convert exactly. So how are we going to be looking at our radians? So let's think about our whole circle. So we have a circle, and we want to be able to look at things in radians. So let's draw a beautiful, even more perfect circle here. Okay, so how do we find the circle? What are some things we know about circles? Well, we know the circumference is equal to 2 pi times the radius. Okay, so let's say our circle has a radius of 1, then circumference is equal to 2 pi. It actually doesn't matter what our radius is because we said 1 radian is going to be the same thing, no matter what the radius of the circle is. So we know here that 2 pi radians is the same as 360 degrees. And if we divide both sides here by 2, we know that pi radians is equal to 180 degrees. So if you multiply the radius times pi, you'll get the distance halfway around the circle, or the angle that gives you halfway around the circle. okay? And the key thing here is that radians are given as a number, and degrees are a different kind of angular measurement that requires a special tool. We can't think of that as a number. Okay, so let's think about what are some of how do our angles that we work with a lot, how might those break down in radians, and how do we go from one to the other? Okay, well, we know that if we know pi radians is equal to 180 degrees, we know that to go from, we know our conversion factor is to multiply by one of these over the other. Okay, so if you want to go from radians to degrees, we're going to multiply by 180 degrees over pi. And if we want to go from degrees to radians, you're going to multiply by pi over 180. Okay, so let's look at some of our common angles in degrees using this. So if we have our, again, our lovely angle in standard position, we think about that going around a even better circle this time. Let's just forget about that first little piece here. Just pretend that doesn't exist. Okay, so we have 0 degrees is going to be equal to 0 radians. Now, 90 degrees, if we're going to multiply it by pi over 180, that's degrees to radians, we're going to get 90 divided by 180, we get pi over 2. So 90-degree angle is pi over 2 right here. Okay, our 180-degree angle, 180 times pi over 180, is going to give us pi. So pi radians is our 180-degree angle. If we go down here to our 270 degrees, multiply by pi over 180, that's going to give us 3/2 when we cancel, so it's 3 pi over 2, or you can write 3/2 pi. And then our 0, which is the same as our 360 degrees, we multiply times pi over 180. That's our full circle, which is 2 pi radians. Okay, so these are the measures of all of our kind of corner angles in radians. 90 is pi over 2, 180 is pi radians, 270 degrees is 3 pi over 2 radians, and 360 degrees is 2 pi radians. So those are some kind of common conversions that you might use. And some of our special angles that we're going to be using that it's worth knowing, we can also think of, if we're trying to find the measure of an angle, we know our whole circle is 2 pi. So if we have an angle that's a certain fraction of a circle, we can think of it as 2 pi times that fraction, because it's that fraction of 2 pi. So let's take 60 degrees, for example. We use 60 degrees a lot. It's in one of our special triangles. So 60 degrees is 1/6 of a circle, because it's 360, right? So whole circle is 360. So if I take 1/6 times 2 pi, 2 pi times 1/6 gives me pi over 3 radians. If I have something here, we've got 30 degrees, so that is 1/12 of a circle, right? There are 12, because 12 times 30 gives you 360. So if I want to do 2 pi times 1/12, I get pi over 6 radians. And then my other special triangle angle that we'll be using a lot is 45 degrees. So that is 1/8 of a circle. And so 1/8 times 2 pi is going to give me pi over 4 radians. So we will be using pi over 2, pi over 3, pi over 6, pi over 4. Those are radian measures that you're going to see popping up quite frequently. And in today's in-class questions, we're going to be taking a look at how radian measure can sometimes be more convenient for things like finding how long the length of an arc is rather than using degrees.